It is with profound sorrow that we acknowledge the passing of Glenn Zieseniss, known online as GWZ2, and a valued member number 48. Glenn dedicated himself to the electrical inspection community for many years. His expertise and dedication to safety were evident to all who had the privilege of working alongside him. While the specifics of his passing are private, it is understood that it was a sudden event and that his family was present during his final moment. Funeral services will take place on Saturday at 1000 am at the Prusen and Little Chapel. Those wishing to pay their respects may visit Prusen and Little Funeral Service in Crown Point, Indiana, on Friday from 200 p.m. to 800 p.m. Glenn's impact on the electrical inspection field was substantial. His contributions were characterized by a deep understanding of electrical codes and a commitment to ensuring the safety of electrical installations. His presence on online forums was marked by insightful commentary and helpful advice, making him a trusted resource for many seeking guidance. He possessed the rare ability to explain complex electrical concepts in a clear and understandable manner, benefiting both seasoned professionals and those new to the field. His absence will be deeply felt by his colleagues and friends in the electrical inspection community. The IE Northwest Indiana Division, along with the broader electrical inspection community, expresses its sincerest condolences to Glenn's family and friends. His legacy will continue to inspire future generations of electrical inspectors. In the electrical inspection world, understanding the National Electrical Code, or NEC, is paramount. The NEC is a comprehensive set of guidelines designed to ensure the safe installation and maintenance of electrical systems. It covers a wide range of topics, from wiring methods and overcurrent protection to grounding and bonding. The electrical inspectors use the NEC as their primary reference when evaluating electrical installations to ensure they meet safety standards. One of the fundamental aspects of electrical work is understanding voltage, current, and resistance. Voltage, measured in volts, is the electrical potential difference between two poles in a circuit. It's the force that pushes electrons through the circuit. Current, measured in amps, is the rate of flow of electrical charge. It's the number of electrons passing a given point in a circuit per unit of time. Resistance, measured in ohms, is the opposition to the flow of current. It's a property of materials that impedes the movement of electrons. Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage is equal to current multiplied by resistance, or volts equals amps times ohms. This simple equation is essential for analyzing and troubleshooting electrical circuits. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to trip and energize the circuit. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. This helps to minimize the risk of electric shock. Overcurrent protection is another essential safety measure. Circuit breakers and fuses are designed to protect electrical circuits from excessive current. When the current exceeds the rating of the overcurrent protection device, it will trip or blow, interrupting the flow of current and preventing damage to the circuit or equipment. Wiring methods are covered extensively in the NEC. The NEC specifies the types of wiring allowed for different applications, as well as the installation requirements for each type of wiring. Common wiring methods include non-metallic sheath cable, commonly known as Romex, electrical metallic tubing, or EMT, and rigid metal conduit. Each wiring method has its own advantages and disadvantages, and the choice of wiring method will depend on the specific application and the environmental conditions. Electrical boxes are used to enclose electrical connections. They provide a safe and secure enclosure for splices, terminations, and devices such as switches and receptacles. The NEC specifies the types of electrical boxes allowed for different applications, as well as the installation requirements for each type of box. Proper box fill is essential to ensure that there is enough space for the conductors and devices inside the box. Electrical panels, also known as load centers or breaker boxes, are the distribution points for electrical circuits in a building. They contain circuit breakers that protect the individual circuits from overcurrent. Electrical panels must be properly sized to accommodate the load of the circuits they serve. The NEC specifies the requirements for electrical panel installation, including the location, mounting, and wiring of the panel. Electrical safety is paramount when working with electricity. It is essential to follow safe work practices and use appropriate personal protective equipment, or PPE. PPE includes items such as insulated gloves, safety glasses, and arc-rated clothing. Before working on any electrical equipment, it is important to energize the circuit and verify that it is energized using a voltage tester. Lockout/tagout procedures should be followed to prevent accidental re-energization of the circuit. Electrical inspectors play a vital role in ensuring the safety of electrical installations. They review electrical plans, inspect electrical work, and enforce the NEC. Electrical inspectors must have a thorough understanding of electrical codes and standards, as well as the practical knowledge and experience to identify potential hazards. They work to protect the public from the dangers of electricity. Continuing education is essential for electrical inspectors to stay up to date on the latest changes to the NEC and advancements in electrical technology. The electrical industry is constantly evolving, and it is important for inspectors to keep their knowledge and skills current. There are many resources available for electrical inspectors to further their education, including training courses, seminars, and online resources. Some additional information to consider is that the NEC is updated every 3 years to reflect changes in technology and best practices. It is important for electrical professionals to stay informed about the latest edition of the NEC. The NEC is organized into chapters, articles, and sections. Chapter 1 covers general requirements, Chapter 2 covers wiring methods, Chapter 3 covers wiring materials and equipment, and Chapter 4 covers equipment for general use. Article 90 covers the introduction to the NEC, including its purpose and scope. Article 100 covers definitions of terms used in the NEC. Article 110 covers requirements for electrical installations. When working with electrical equipment, it is important to follow the manufacturer's instructions. The manufacturer's instructions provide important information about the installation, operation, and maintenance of the equipment. Failure to follow the manufacturer's instructions can void the warranty and may create a safety hazard. Electrical permits are required for most electrical work. The purpose of an electrical permit is to ensure that the work is performed in accordance with the NEC and local codes. Electrical permits are typically obtained from the local building department. Before starting any electrical work, it is important to check with the local building department to determine if a permit is required. Electrical inspections are typically required after electrical work is completed. The purpose of an electrical inspection is to verify that the work has been performed in accordance with the NEC and local codes. Electrical inspections are typically performed by a qualified electrical inspector. If the work passes inspection, the inspector will issue a certificate of compliance. If the work fails inspection, the inspector will issue a notice of violation, which will specify the corrections that must be made. Electrical troubleshooting is the process of identifying and resolving electrical problems. Electrical troubleshooting requires a thorough understanding of electrical circuits and components, as well as the ability to use electrical test equipment. Common electrical problems include open circuits, short circuits, and ground faults. When troubleshooting electrical problems, it is important to follow safe work practices and use appropriate PPE. Electrical safety audits are conducted to identify potential electrical hazards in a workplace. Electrical safety audits typically involve a review of electrical equipment, wiring, and work practices. The purpose of an electrical safety audit is to identify and correct any electrical hazards that could lead to accidents or injuries. Electrical safety training is essential for all employees who work with or around electricity. Electrical safety training should cover topics such as electrical hazards, safe work practices, and the use of PPE. Electrical safety training should be provided by a qualified instructor. Arc flash is a dangerous electrical phenomenon that can occur when there is a short circuit in an electrical system. Arc flash can cause severe burns, electrical shock, and even death. Arc flash hazard should be assessed and mitigated in accordance with NFPA 70. Article 230 of the NEC covers service entrances. The service entrance is the point where electrical power enters a building. The service entrance includes the service conductors, the service equipment, and the grounding electrode system. The service entrance must be properly sized to accommodate the load of the building. Article 250 of the NEC covers grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protection devices to trip and energize the circuit. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. Article 300 of the NEC covers wiring methods. The NEC specifies the types of wiring allowed for different applications, as well as the installation requirements for each type of wiring. Common wiring methods include non-metallic sheet cable, electrical metallic tubing, and rigid metal conduit. Article 310 of the NEC covers conductors for general wiring. The NEC specifies the ampacity of conductors, which is the maximum current that a conductor can carry safely without overheating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. Table 310.15b16 in the NEC provides ampacity ratings for various types of conductors. Article 400 of the NEC covers flexible cords and cables. Flexible cords and cables are used to connect portable appliances and equipment to electrical outlets. The NEC specifies the types of flexible cords and cables allowed for different applications. Article 430 of the NEC covers motors, motor circuits, and controllers. Motors are used to power a wide variety of equipment, from pumps and fans to compressors and machine tools. The NEC specifies the requirements for motor installation, overcurrent protection, and control. Article 440 of the NEC covers air conditioning and refrigeration equipment. Air conditioning and refrigeration equipment consume a significant amount of electrical power. The NEC specifies the requirements for the installation, overcurrent protection, and control of air conditioning and refrigeration equipment. Article 500 of the NEC covers hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC specifies the requirements for electrical equipment installed in hazardous locations. Article 517 of the NEC covers healthcare facilities. Healthcare facilities require special electrical systems to ensure the safety of patients and staff. The NEC specifies the requirements for the installation, grounding, and bonding of electrical systems in healthcare facilities. Article 547 of the NEC covers agricultural buildings. Agricultural buildings often have unique electrical requirements due to the presence of livestock, moisture, and corrosive materials. The NEC specifies the requirements for the installation, grounding, and bonding of electrical systems in agricultural buildings. These are some of the key topics covered in the National Electrical Code. Electrical professionals should have a thorough understanding of the NEC to ensure the safe and compliant installation of electrical systems.